This is Lando. He is a corgi. He likes chewing on socks and going splish splash in the water, but he has a flaw. He won't stop barking. He barks when he is happy and he barks when he is sad. He barks at the wind and he barks in his sleep. He pretty much is made up of only barks at this point. Today we are going to use computers to train it out of him.
So yeah, my dog barks, but how will computers help? There's two parts to this. First, before it can do anything, we need to get actionable data. When he barks, how much he barks, patterns, habits, we can use it all. And spoiler, this is where we can get a little boost from machine learning to help us determine when Lando actually is barking. And second, we need to try to find a way to automate a response that corrects him when he is barking and we're not there. But before we get to that, we need to talk about where we started before this. And I want you to meet another member of our family, the Furbo. Why is it a member of our family, you ask? Good question. It's chilling in our living room, watching and listening to all of our conversations, just like a good member of the family would. For those of you not in the know of the pet-centric IoT world, a Furbo is essentially a webcam with an app that has a few standout dog-type features. The main one of these is it has a built-in treat tosser, not the most practical thing in the world, mostly because no matter what treats we use, it just makes it rain down a dozen of them, creating this cluster bomb effect of treat splash damage. Not really practical, but damn good fun. The other features are more in line with the fact that it has a built-in two-way mic and speaker combo, and with that it claims to have bark detection, and it works pretty decently. When it detects a bark, it will send a push notification to our phone, where we can then talk through the device to our dog like it's some sort of speakerphone. The real problem and limitations for us with this feature are twofold. First off, it's strictly reactionary. Not that I need proactive Minority Report style precogs like it's a Tom Cruise movie. Well, maybe. Building a precorg might be a kind of fun future iteration of this for a future video. But back to the now. We want to remove us from having to respond every time there's a notification. Not only is this response manual, but it's usually delayed. This works when he's having a large barking fit and he needs calming, but that's the only time we can respond in a timely manner to actually address the barking. The other problem is the bark detection itself. In our case, it gets a decent amount of the barking, but it also triggers on laughs, the TV, gardeners outside, and so many other things. From what I can perceive, and I don't have info to back this up, so please don't sue me, it's just a noise threshold setting. Maybe there's some pitch stuff going on here, I don't know specifically. But I started thinking this shouldn't be too hard to do ourselves. And it wasn't. I created a basic Python script that would record audio using PyAudio, label and record events over a certain noise threshold, and bam! I have a program that records audio and tracks when it's triggered on a bark. Still being aware of false positives this would have, just like the Furbo, this gives us a good baseline. But where am I running this, you might ask? Not a Raspberry Pi, because apparently people are doing hobbies again or something. I just started with an old MacBook. Bonus, it already has a built-in mic and decorations from Kevin of a different era. I threw this in the living room where the corgi spends most of its time, and also where we leave him when we're not with him, and just let it run collecting data. I was putting this data into some dashboards I created using Dash for Python, a pretty cool tool for the front-end adept like myself, and here we are getting some bark data over the course of a week. Here's where I started moving on to the next phase, the actual reinforcement side. Well, the reinforcement of the dog habits, not machine learning reinforcement, yet. Basically, what do I want the program to do when it knows Lando's barking? And we can start with something that didn't work. High-pitched sounds or dog whistle style sounds as a negative reinforcement. He absolutely hated this, and it just made him bark so much more. This also felt like punishment, and I didn't really want to do that. Now, I get it. Here comes every certified dog expert in the comments telling me something like, you need to tell your dog who the alpha is. That's not really how we like to train him. Doesn't mean we won't tell our dog to stop or acknowledge verbally when we don't like something he's doing, or even give them a bit of a timeout away from everyone when he needs to settle down. But we got a dog knowing that they like to bark. So I don't like the idea of causing discomfort or pain, even if minor, for doing something they just do naturally. So let's talk about other responses we could use. And that's my voice. Well, specifically, when it detects barking, we need to give him verbal redirection or stimulation from my voice. Now, the Furbo already does this. I don't want to just copy the Furbo here because I don't love the implementation like I mentioned before. Once you as a human react, it's potentially too late, so we can automate our response. I created multiple pre-recordings of myself calming him down in different ways, and I would also play a random assortment of these to calm him down when triggered. I also adjusted some of the logic when a certain message I thought should go in a certain order. For example, as a last resort, we have this sound. Hey buddy. Could you just actually shut the I didn't use that one. I'll spare you sample the real ones with the baby talk. So how did this work? Well, very quickly, false positives were a bit awkward. Like, this could not run with any humans in the room. Then it would just turn into a weird noisemaker, my voice. I probably could make some adjustments on how and why it triggers, but I think we actually just need to get better at the detection of the barks. And that's where we can use machine learning. I'm not an expert in ML at all. My specialty is in a completely different side of software engineering, but I'm pretty decent with the programming language Python and found some few good talks online to solving similar problem sets. I also found some example code by a data scientist named Nicholas Kridler that has done something similar. And this allowed me to establish a plan. For you nerds out there that care, I'll also link these down below. But speaking of nerdy, we do need to step a bit into how I'm actually building this model. The plan was to use a tool called Keras, which is a neural network library. This is going to help a noob like myself interact with the underlying machine learning platform called TensorFlow. For those of you that don't know TensorFlow, it's the standard open source machine learning platform. Created by Google's Brain team, it's kind of the go-to for most machine learning algorithm creation. I'd go as far as to assume the YouTube algorithm that might have helped you find this video is running on TensorFlow, or at least has TensorFlow somewhere in its stack. But these tools on their own don't know what a bark is, or even more specifically, what a Lando bark is and sounds like, so we need to teach it. We do this by using pre-recorded and labeled clips. Labeling meaning we tell the program that these are Lando's barks. These clips are converted to a spectrogram, which is a visual representation of the audio clips. The model then uses these audio clips as a template to match future barks against. When the model does this matching, it doesn't just tell us yes or no if it's a bark. No. That would be too easy. The model returns a level of confidence that the two items are a match, and I have to determine at which confidence level I think is a sufficient match. Okay, we're getting kind of boring. Which matters here is it's working, and I have machine learning registering and distinguishing Lando's barks. We just throw it on our dashboard and we have succeeded. Everything is dandy. Well, I now need to build the initial model on my PC to utilize the GPU. And I also want to be able to iterate rapidly and not have to move the program back and forth. But my PC is a bit away from the living room. So I tried streaming from the laptop to the PC upstairs, and that caused some weird issues I won't get into. But then I remembered the Furbo and the lovely world of IoT. You know what they say about IoT? The S stands for security. And using all my years of crafted hacker skills and experience, we're now connected to the Furbo, streaming the camera to my desktop. Okay, I just skimmed over that. I feel the need to explain what you just saw on screen. The username and password to connect to the device that is recording audio and video in my living room is admin. But we're now connected and able to run the program from my main PC, streaming from the Furbo's mic and camera. A little bonus here is I am now able to create a little web app that will stream the data from the Furbo, so I no longer have to go through the Furbo's app to actually just see the webcam footage. But back to the program. Now we need a speaker in the living room for our automated response. I tried getting the Furbo speaker to work, and I spent a lot of time on this, and in fairness to the Furbo folks, it actually is locked down, so I couldn't get that working. I also have Alexa next to it, so I was trying to send a signal from that, but you can't really do that locally. I was then gonna build an Alexa skill, but the architecture to do that looks like this, and we are getting into the weeds again. I threw a Bluetooth speaker next to it and connected from my PC to the Bluetooth speaker and called it a day. And this actually did work. Now that we have a better bark detection that doesn't trigger on every random progressive commercial, we have automation for the responses. This allowed me to revisit the automation. We can fine tune the triggering of the automated messaging. Do we want to trigger on every bark? No, we definitely don't. We're looking for a response to a behavior we don't want, which is those multiple barks in a row. This required a bit of hand-wavy fiddling, but it came down to about 6 barks in 18 seconds, which the software records chunks of 6-second intervals, so 3 chunks with 2 barks would get a trigger. This is good for those barking fits, but it is a bit slow. The quickest we get a response is around 15 seconds. The reason we have to wait 6 seconds, and the problem is the way that we built the model earlier, is that we need to record a chunk of audio, in this case 6 seconds, and then process that 6-second clip for the barks. But sometimes the dog just goes berserk. He is a puppy, and we want a quicker response where we don't have to wait 18 seconds. But we also want to still keep the level of clarity we're getting from using the machine learning algorithm. So what I did is I programmed in, if a 6-second chunk gets 4 registered barks, it would then trigger a response in the next 6-second chunk if any sound broke the sound threshold limit we were using earlier. This method allowed me to be sure he was barking and then still quickly respond if he continued to do so. We can be pretty confident that if we have verification he's already barking, the next sound is probably him still barking, and we don't need to wait for the ML algorithm to process it 6 seconds later. And then we can get our automated response and we're good to go. Our application was running on the machine learning model, recording the data and triggering responses. So did it work? Did it do what we wanted? Is he no longer having these barking fits when we're gone? Kinda. COVID made this experiment more difficult because we didn't have long uniform stretches of time away from him like we would when me and my partner are going to our jobs. So I can't yet comment on the long structural changes here. But there are a few places in the data that we did get something similar, where we would see the barking stopped after the responses, when in other similar situations, he would continue to bark when the automation was not running. This very fact that we can see him bark, the trigger would happen and then he stopped, even if it is only for a few minutes, is successful. But there was even a cooler outcome here, and that was the data we got. We didn't run the reinforcements all the time because it's in our living room and I don't want my voice coming out of a speaker all day long. But we did record the whole time registering barks, and we got to see some cool patterns. In fairness, some of this could be coincidental. I'm conscious of the bias we have applying attributes after seeing the data, but we saw a few things here. For one was the times in which he barked the most. We knew before we saw the data that he loved to bark early in the morning, and as the sun's going down, he gets super hyper as well. But we noticed he also tended to bark a lot during lunchtime, as he probably got a little bit bored midday while we're both usually busy working. Also, we love seeing the data from when he went to doggy daycare, or really anything that was high energy for a long period of time, like when he's hanging out with his cousins that are 2 very playful, older, bigger pit bulls. What we saw in the data was that he basically barks significantly less the day after one of these outings, at the cost of a much louder evening after we got home from the fun. Which makes sense. He was excited still from all the fun he was having, and then the next day he was tired. But it's cool to see this data and be validated by it. So in summary, it was a success. It seems to actually help calm him down when we're not around, and more importantly, we're getting some cool data. It's making me think of things we can still do with it.